and our speaker, Vivian Liu. Vivian is a PhD student at Columbia, where she's advised by Lydia Chilton. She's also a student researcher at DeepMind. I first met Vivian about a couple of years ago, the time when you were working at Autodesk, and we collaborated on a project involving natural language-based 3D shape generation. Since then, she's been doing a bunch of interesting work on the intersection of AI and HCI, particularly around how do we actually integrate generative AI tools usefully into real artist workflows for things like animation and 3D design. Vivian is also a fellow UC Berkeley alum. Go Bears. All right. Yeah, so without further ado, please welcome Vivian.
Hi, everybody. I'm super excited to be here. Fun fact, in 2020, I watched one of these seminars that Daniel gave, so it's kind of insane to be coming back full circle. He mentioned that I am at Columbia, advised by Professor Lydia Chilton, and I am currently an intern at DeepMind, so I can answer a lot of questions about my research, but also if you have questions about just being a student and intern, feel free to let me know. My talk today is titled Enabling Design with AI Through Interactive Techniques for Multimodal Integration. And that was a mouthful, right? It was a lot of words, but first I want to start off with a simple definition of what is a modality. So we talk about multimodal a lot, but what does it mean? Modalities, the definition is channels through which we gather information about the world. And it's made clear through examples like things like image, sound, and language. And they're this form of natural input and output that we have with each other, as well as with computers. And as people, we have really strong perception. We have these perceptual abilities that allow us to understand different modalities at different levels of abstraction. So I'm going to draw a chart out. And here we're going to see, first there's an image there. And all of us can recognize, okay, those are some birds in the sky. It's a photo, it's a very detailed form of image. But interestingly, we can also just draw 3 marks on a page and equivalently understand, oh, those are birds. So that's a form of visual abstraction that we have. But we also have this sort of capability in other modalities, for example, in language. So see here, we know when we're browsing through Reddit and stuff, people are like massively dumping information about their lives, but we often don't need that level of detail. We can just get a simple TLDR. So it says TLDR, I put my friends to see a show, et cetera, et cetera. And we work over these different modalities so that we can combine them into a meaningful form to represent our thoughts, our experiences, and our visions. So many of us here, well, we write research papers, and we know that those are not just papers, not just language. They're also figures and videos to transmit that idea across different mediums. When we're watching YouTube or TikTok, that's music plus video plus scripts and voiceover. Or as computer scientists, when we build systems and tools, what we're doing is we're creating interfaces that have language and image, but all of that is powered by code. And so I want to break down this last example of designing an application to show how we're working over different modalities to achieve these complex and creative goals. So for example, say we have a simple thought, like I want to make an online shopping application to become a CEO, yada, yada. That is a high-level thought, and that's in language. And so that's our first idea. And what we do after that is we figure out ways to externalize it. So we might go to a Notes app or to a Google Doc and make that more precise in terms of language. But there's other ways to externalize moving across into another modality as well. We might take pen and paper and then start sketching out our ideas in lower fidelity. And that gives us some intermediate representations. We have documents and mixed sketches. And then to move it into even higher fidelity, we might make UI designs. Or to get it into more of a code form, we might go to the whiteboard and start drawing system designs, high-level understandings of code. What are the frameworks we want to use, the different languages or abstractions that we want to learn, and so on. And so from those intermediate representations, then we're able to finally write that code to execute that idea. And so this goes to show that to help our ideas take form, we have to walk them across different modalities and also different levels of abstraction. But as computer scientists, we know that it's not this clean feed-forward pass. There's always feedback, and evaluation and iteration are really key to improving our work. So for example, you know that there's always bugs, and so we have to go back into the code domain to fix them. Or there might be UI design issues and usability issues, so we have to take it into the visual space. Or sometimes at some point we realize the idea just has flaws and we have to go all the way back to the drawing board. So what I'm laying out here is a design process. And this design process conceptually models how people approach complex and creative work. There's different stages. There's ideation, design execution, evaluation, and iteration, which moves people through these different stages. Now, of course, I was modeling how people traditionally approach creative work with other people, but what does it mean when AI is in the picture? Well, enter AI. It has like really remarkable multimodal capabilities connecting across modalities. And what I love about this chart is that it shows that sort of power move that AI gives us. So it lets us work at higher levels of abstraction and really accelerate past a lot of low-level details. So we can say or think, like, make me a financial charts application, and we can get an application that looks like this. It's pulled in data visualization libraries, they give us the code, and that's pretty amazing. But at the same time, we know that it's not perfect and that working with AI can often be very frustrating. And why is that? Well, another way to see it is AI lacks the flexibility across different modalities that we have. And so oftentimes, at first, what seems like this shortcut across different modalities ends up being this really long round trip when we try to iterate and interact. So we might say to an LLM, well, here's that nice application, but what do I interact with? There's no features for interaction. And then that large language model could be like, oh, okay, well, I'll add these fields for you. And you could be like, oh, well, I want more features. And then it comes back again, but this time that application can come back looking entirely different. And why is that? Well, it's because AI tools don't have the same structural handshakes or intermediate representations that we traditionally have with system designs and UI designs and so on. And so it gives us these shortcuts, but they don't lend well to control, iteration, or error recovery. So then, how then do we enable design with AI? My work puts forth different interactive techniques that have multimodal integration at each stage of the design process. So the first stage of design ideation can be supported by a technique that I call multimodal switching. And that's when you switch between different modalities depending on what they're strong at in a structured search for ideas. The second stage, design execution, can be supported by cross-modal mappings. That's when you create mappings across different modalities to express meaning that's more than just the sum of the parts. In the third stage, design evaluation, that can be supported by a technique called multimodal reflection. And that's when we integrate a lot of information from different modalities into a representation to build upon. And then I'll be talking about how iteration can be supported by a general framework that encapsulates all of these different techniques. And so altogether with these techniques, that can help users iteratively focus that expressiveness that we get from generative AI and interactively align it with the goals that people have for creation and communication. So I'm going to give brief previews of each project before I jump into each one of them. So multimodal switching in support of design ideation. To speak to this project and this technique, this project is called Opal. It is a text-to-image system that shows how conceptual exploration in language can help structure the exploration in visuals around news illustration. So the modalities here are language and image. The next project is about music and video, and it's going to show how the technique of cross-modal mappings can support design execution. So it's called generative disco. It helps users make music visualization and create cross-modal mappings between music and video to express things like the emotions and the narratives within music. And then I'll be speaking about a technique called multimodal reflection and how that can support design evaluation. So this project is called Locomotion. It will integrate information from Canvas understanding, so visual information, as well as world knowledge from language into animation code. And it's going to go from a static document to something a bit more exciting like an animation in that bottom corner. It also reflects on visual information from the canvas after the code has been run, so that if there's any errors, the LLM can assist the user in self-debugging itself, thus helping with error recovery. And then I'll be also talking about how these techniques tie together in a general framework for multimodal interaction with AI, because ideally a tool should be able to combine all of these different methods so that there's support at each stage of the design cycle. I'll be touching upon some ongoing / future work when I return to Columbia. It's called Canvas Agent, and it's in support of design iteration. So that will be a agentic framework where there's a number of different agents, all with some specialized role for ideation, execution, and evaluation. So that's the talk outline. I'm going to get into it by first speaking about Opal. So Opal was multimodal switching for ideation. And so now we're going to hone in on a target artifact, so something that people create. Opal specifically was about producing ideas for news illustrations. And probably today you've already seen a couple of news illustrations, but just to have a clear definition, it's the sort of images and illustrations that accompany journalism online to encourage readers to read it and to have some click-through. Columbia is very invested in journalism, and so talking to a lot of journalists from a co-design process with news illustrators over a couple of months, what we learned is that when people are doing news illustration, they often have to work under a lot of time pressure because the news cycle is 24 hours, it's ongoing, it's very fast turnaround. So illustrators usually they pick a concept and they go. They don't really have a lot of time for ideation or visual exploration. But at the time in 2022, text-to-image AI was new, and it was this powerful technology that had a lot of expressive capability. And some of the earlier work in my lab that I did was about understanding that it can provide a lot of different subject inspiration and style inspiration. And we thought maybe this could be beneficial for news illustrators. So what Opal does is it guides users through a structured search for visual concepts around news content. And it switches users between that conceptual exploration, which is facilitated by a large language model, GPT-3, and visual exploration of a design space, and that's facilitated by a text-to-image model, which at the time was VQ-GAN plus Flip. So I'll walk you through the system design first abstractly before I show you guys the interface. What it took in as input was a news headline or article text. So that news headline could be something like, climate change is speeding up sound in the ocean, that's bad for marine animals. And what it did was it first would provide 3 pipelines for conceptual ideation. So what are the sorts of keywords, article tones, or artistic styles that might be relevant to this headline? And what we would do is we would expand out in terms of extractive summarization and abstractive summarization, different words that would be relevant to that headline. So for example, we can see that sea life and rising temperatures, those would be keywords related to that headline. That article could be concerned in tone or argumentative. And in terms of artistic styles, maybe black and white photos or documentary photos or fisheye photography could be relevant. This expansion was led by GPT-3. However, at each stage, we also would move laterally into a new modality, and VQ-GAN plus Clip would visualize that keyword or that tone. So for example, sea life in the style of a painting could look like that, or concern would look like that. Now, something that's interesting about language is that it's really good at capturing abstract things that we can't see in front of us, like climate change or maybe sea life and so on. But things that are visualizable tend to be more concrete in nature. So we have this insight that maybe if we had an abstract to concrete expansion step, that would make it easier to have better subject representation and things that are more easy to visualize and generate. Because sea life, you might get something that has poor subject representation, but if you put in a whale, that could be better. It's more apparent in this like smiley face example. And when users would hone in on a subject, we would also recommend and match styles given chosen subjects and tones. So Opal in user interface form looked like this. So on the left side, there was all this conceptual exploration where GPT-3 was populating the user interface. Whenever users would move to a different stage, generations generated by VQ-GAN plus Clip would then stream back. And so that's how it was moving users very naturally between different modalities. So to evaluate Opal, we did a technical evaluation and a user evaluation. The first one was evaluating an LLM's ability to go from abstract to concrete. Now this was in 2022. GPT-3 had just come out. At first, GPT-2, which the lab was working with, was very random and tended to be a little bit unfocused, so we needed to validate this. We did 5 annotation studies comparing human performance with GPT-3 performance. And obviously humans were better, but GPT-3 at least was capable of doing this abstract to concrete expansion. And we also benchmarked against traditional NLP approaches, such as semantic embedding-based search. And we also conducted, I guess what is called a perceptual study, perhaps, but we did a user study, which was a within subjects evaluation of Opal. And we compared it with a baseline, which was just a prompt-only interface. And what we found was that in the same amount of time, Opal's multimodal switching for ideation technique helped people find over double the amount of usable outcomes within the same amount of time.
Can you elaborate on what this prompt only interface was like? I think if I get a sense for it, just by looking at the screenshot.
Yes, it is simple. So it's being able to just write in a text prompt. And at the time, that is what was primarily exposed by a lot of the notebooks that people would have, interactive notebooks interacting with these models. And so we wanted to see, well, if you have a structured pipeline, how does that compare with the open-ended one?
I see both of the interfaces, you can actually paste in the text of the input article as well.
Yeah,
How is that taken into account? I mean, I think I understand how it's taken into account in Opal system. How does it take into account in the baseline?
in the baseline, quite simply, we would just return, so that would be like synthesized into a shorter prompt, like a summary, and then typed in as a prompt so that users could still see, like, oh, here's an immediate generation.
Okay.
Kind of, like what their appetite for what the generative model could do.
So it would like summarize the article into a prompt, which the user could then choose to edit if they wanted to and go from there. Okay, got it.
Yeah.
Yeah.
People tended to get very experimental with this sort of text-only baseline, and I'll touch upon that. So like I said, it definitely validated quantitatively that they could ideate more. But what people said was that they found it, yes, useful for ideation, but why? Well, it was cumulative and it was focused and it was able to drill down on visual concepts. Usually when presented with just a text box, they started to get very experimental. They didn't know how to really structure that exploration. And so they felt like they were kind of going to ground zero each time. One quote from a user was, "It's nice for generating ideas, good for cherry picking. Here Opal spits out so many, I can just do this forever until I get that one ideal one." By this they mean idea. And they liked being able to go, more concrete. They would say like, okay, keywords are good, and they give me directions of where to go, but sometimes they could give me generic images, and I liked how these icons could get more specific and more rich conceptually. And even when illustrators would come in with inspiration of their own, like they would read it and they would instantly think like, oh, I have an idea. The system could still help them build upon that idea so that it would give them more clarity in terms of things like color palettes, backgrounds, and so on. So that's Opal, and it's representing multimodal switching for design ideation. It's when you use the strength of one modality, like language, to help structure exploration in another modality. And it helped with the ideation around news illustrations. There was also a follow-up work called 3DALI, and that showed that multimodal switching also applies in the 3D domain. And language can also help with 3D design, even though those modalities are a little bit further apart than language and image. And in this system, we looked at other conceptual dimensions like standard designs. For example, a Batmobile brings something to mind that is very different from a pickup truck or a bumper car, etc. Or different styles, like whether something is supposed to be retro or low poly. But also from understanding literature around how people CAD, you're realizing that when you're composing a 3D design, you have to think in terms of parts. So designing the tire first, or the tire chassis, and so on. Something nice about this interface was that when people got image inspiration, they were able to put that in as a blueprint, particularly when it was like from a front view, a side view, or a top view, and build upon it. So that was also a form of ideation. And so this idea of multimodal switching in Opal and 3DALI has had industry outcomes and recognition. So Opal was featured in TechCrunch, 3DALI was patented. Microsoft's chief science officer actually reached out and said that he wanted to feature 3DALI in a talk, the Tanner Lecture on Human Values, and he called it a pointer to the future, which is cool. And 3DALI was also tech transferred into Fusion 360 as a plugin called Project Salvador. So it's actually something that you can use, and it's pretty cool because one day you're doing a research paper and then later on there's a brainchild to it and it's a product, or it's part of a product. And so this was a cookie cutter cow that I was able to CAD in about a couple of minutes, which is really cool because I can't CAD at that ability. So that was Opal and 3DALI. Now I'll be talking about another technique, cross-modal mappings for design execution. And this one will be talking about generative disco. So generative disco was a fun project I did in 2023 with a lot of different collaborators. Tao, Nathan, Jenny, Joshing, Yumo, Claudia, Lulu, and of course, my advisor, Lydia. And so this one looks at two modalities that are very deeply intertwined. So music and video often come together in a lot of different cultural productions. So for example, if you guys remember Windows Media Player, Winamp, and so on, dance is another form of that, and also concert visualizations. So I used to freelance and I used to work at this design agency called All of It Now. and everybody around me was a visual jockey, which meant that they created visuals to go with music. So I was kind of personally interested in what sorts of stories people could create, specifically with a text to video model around music. So I'm going to play a video, and Daniel's going to help me with the audio here. Let's see. Okay, so what you guys can see there is that there was some potential with these models. They had audiovisual alignment, which we had some latency, but there was some potential. I'll just play it once more without audio so you can see that there's this kind of new potential in the visual quality. It's like seamlessly going from like one image to another. And so text to video models presented a lot of potential for people to create these visual narratives, but constructing a message that takes place over time is pretty different from constructing a still image. A still image is just a spatial composition. But when you're working with time, text to video models have these new variables like the amount of visual change or the speed of motion. So I'll play these videos. If it's okay, can we, mute here. Right, I don't know. And that music would render as a waveform representation. And then once they had that in there, they could start doing exploration. So again, there was a brainstorming area, and they could explore different visual concepts from GPT-4, as well as a knowledge base from videography and some formative work to understand music videos. We watched a lot of YouTube for this. And then what they would do to define that cross-modal mapping is they would brush across an active interval in the music, and they would drag images from this gallery to keyframe the start and end of a video interval. So 2 images would map to a video interval. From there, Disco would implement these cross-modal mappings through interpolation. It would take those images, get their image embeddings, and then interpolate them in the latent space. And the steps of this interpolation were informed by the music analysis. And so that's how we would get audiovisual alignment. And then when you concatenate all of these different audio reactive text to video intervals, then you have a form of music visualization, and you get to produce a visual narrative around music. So Now I'm going to show a couple of examples to show these different sort of cross-modal mappings and how they express different layers of music. The gentle introduction to it. We'll go harder and faster with Daft Punk. We'll see what happens. Oh, no, it's memorable. And then, lastly, another type is like expressing a lyric, right? Like you don't want to just get musical elements, you want to see something more higher level.
Justin Bieber, you know I'ma hit him with the ether. Runs out, wiener, but I gotta keep an eye out for Selena.
Works, right? It's like remix and looping. So we conducted a user study with music artists, music video, and video editing freelancers across the world. And of course, we were quantitatively evaluating like, oh, okay, does that have enough creativity support? And does it reduce cognitive load? But what was more interesting was the sorts of qualitative insights that we got, like what cross-modal mappings people actually wanted to create. And so musicians were actually talking about it. They were saying, yeah, I think about music and how it can render visually. So here's one quote, and then we'll play the video. Songs can kind of sound brighter or darker, depending on what sound you use or the frequency range that's dominant. You can think about how color might inform our understanding of sound, like frequency range of darker colors mapping onto the shorter wavelengths on a spectrum. So somebody had an original composition that they made out of yerba mate bottle caps. Those are yellow bottle caps. And they thought, I want to express that feeling of yellow and morning. I think we can skip the rest of the music. I think you guys got that idea. Professionals felt that AI, and thank you, felt that AI can help them overcome a lot of time and resource constraints. So they would say things like, okay, well, looking for footage to use is really time consuming and it's probably their least favorite part of the workflow. And it can also be really expensive. And so they would say that if they were doing it without the help, it would take a lot of like cutting to the music. But the way that the system would do it, they felt like it was kind of flawless how it transitioned on the beat. And they also felt that it could help them with design execution and do visual techniques that are outside of their usual abilities. So for example, a video professional might have a skill set that they're pretty used to, but then they would be able to move into an adjacent one, like being able to do stylized morphing or stylized animation and get interesting effects like this that changed over time, subject, style, and color. And so disco captured a phenomena that we call double hatters. And our user study, its primary insight was showing that disco could enable this sort of horizontal expansion across different domains like music and video and help people with skill mobility. And this was especially important for the freelancers that we interviewed who had to often wear a lot of hats to accomplish their jobs. So disco is a project that I'm proud of because it has a lot of like other impacts. So I used it as a sort of outreach tool this summer. Disco was presented to 171 girls who are ages 8 to 18 for this NGO called STEM from Dance. And they reach out to girls through programs that integrate dance and physical computing and computer science all together in summer programs. So people make these like light up costumes and they have like a dance showcase and so on. I think that disco was this really nice tool for helping excite people about computer science because when you're 9, I don't think maybe you don't even care about programming a game. You care about watching a music video or enjoying dance or so on. So that was nice. And 20 students participated in the workshop, creating text to video music videos at the Barnard Movement Lab. So that's Disco. It allowed people to create these mappings between music and video to express the emotions and narratives that are within music. And now I'll be talking about the third project, which is multimodal reflection for design evaluation. Now, this one is embodied by this project called Logomotion. There's no audio, but there's going to be a lot of motion. So you can see here, these are logo animations, and these were all created by Logomotion. This was done in collaboration with Rubaya Kazi, Li Wei, Matt Fisher, Tim Langlois, Seth Walker, and of course, my advisor, Lydia. So I had just come off of Disco and I was working with Adobe, and they told me, well, why don't you first think about like what makes motion a powerful tool? Well, motion is super powerful because it has this ability to kind of suggest life. And I think these examples really show it. Motion designers usually use animation to signal change, like, okay, like a day is passing by or time is passing by, or to convey personality, like these googly eyes, or connect objects to actions and activities that something might take on in the real world. So this cat is kind of lazing around, but if we think about it in terms of animation, maybe it's just some scaling and easing that really expresses that. And so animation really works and is really delightful when it reflects and reinforces the semantic relationships that are on the canvas. So for example, this UFO is going up, we expect that because UFOs go up. A car drives into the screen as expected, and it matches the visual expectations for how we think this object should move. Fans kind of blow wind, the text is blowing with it, and bubbles rise up. But creating this sort of animation and getting the feel for motion right is really challenging because it takes a lot of time, effort, and expertise. And so usually what design tools do is they offer users a ton of like templates and galleries, so thousands that cover different use cases and different compositions of graphic elements. And to customize and edit those templates, they give people motion presets. Motion presets like fade, spin, pop in, the sorts of things that you see on PowerPoint and so on. But what Logomotion did was it took a generative approach. So to expand beyond that fixed preset of motion presets, it animates logos by having a vision language model reflect on the elements on the canvas to generate code. In terms of input and output, the input was this PDF, and it was this layered document of text and image elements. That's all static, but after Logomotion, it would become an HTML page that would be driven by animation code. And so you could get something more exciting. So as a vision language model system, it would help users automatically and interactively animate static logos. So there's 3 different stages to this, and I'll step through them. But first, at the high level, what they are. The first one was visually grounded code synthesis. So this stage would automatically produce candidate animations for a logo. And what I find exciting about this stage is that it introduces a lot of vision language model operators for automatic layer understanding, automatic layer grouping, visual hierarchy analysis, and the integration of world knowledge. And then there was a second stage for visually grounded program repair. And so this stage noticed that sometimes there could be just bugs in the code. And what if we could utilize visual feedback from the canvas to help self-debug those animation code errors? And lastly, those 2 approaches were automatic, but as an HDI researcher, it's about adding interactivity. In stage 3, we allowed users to use a dynamically generated action panel for editing, and it included widgets for layer regrouping, a narrative timeline, and has some quick actions so that users can edit the motion, grouping, and timing of their animation. So now I'll talk about the system in more detail. So Logomotion starts off as this PDF with different text and image layers. A first simple step is a vision language model captions each one of them, and then pulls it into an HTML representation. And this is the first pass, so it pulls in those captions, but it also takes structured information like bounding box and z-order information, and it creates this HTML. Then there's this additional processing to augment that HTML with image analysis. We took, again, a VLM, and we classified different elements and layers on the page based on the visual hierarchy within the image. So we identified, okay, the sphere is the primary element, and its orientation is facing the right. So in terms of the animation, it should come in from the left. Additionally, there's certain elements that might conceptually group together, like these mountains. So these mountains could be a secondary group. So it's recognized as secondary to the primary element. And from that augmented analysis, we reorganized the HTML representation so that the intermediate representation had all of that information. then we had a step where we were suggesting a design concept. So now we have code and we have this image, but what we wanted was a design concept in natural language. And in this way, we could pull in knowledge, world knowledge. So for example, how should a sphere slide into view? Should it do a trick, etc.? And also like it would assign a hero moment and also sequence all the other elements in. What's nice about language is that there's like a structure to it. There's like first, then, and then last. So we got some sort of temporal sequencing from this. It was also good because we could lift this later on for interactivity. So from there, from this design concept, now that we have 3 different modalities, we took a vision language model and implemented animation code. And so that was JavaScript animation code. And I just want to highlight one reason why we chose to use code as a representation. Code is really succinct in being able to express what is changing over time and space. And so that was something that I thought was nice about this representation. And so that was the first stage. It showed how locomotion can accomplish both ideation and execution so that you could get animations like this. However, the second stage acknowledges that there could often be errors with these code. So for example, you could see that the sphere on the left is jutting in front of the text, but locomotion could also self-debug those code errors, thus supporting evaluation. So I'll walk through how it did that. So there was a checker that would check layer-wise. It had a layer-wise V-mode focus. And when it identified different errors, for example, the position error there, it would create a bug description, and it would also pass in the code that had that bug. Afterwards, it would generate a code snippet that fixed that bug and merge that back into the code. And so in this way, we had this loop where there was this automatic understanding and self-debugging. And so that created a feedback loop back to the LLM.
Can I ask how the bugs are detected? Was that using a VLM as well, or was that just using something like saying, hey, when the animation finishes, the skier is not in the position that it is in the final HTML?
Yeah, exactly.
Okay,
We use like a Selenium web agent, and then we just check layer-wise and element-wise.
got it.
Yeah.
Quick question also regarding the, if you go back a few slides, there's the conceptual understanding part. Also, I guess, bug understanding part, is that something, are those like, yeah, maybe like a more, back?
There's a bit of a lag, so.
Oh, sorry. No, what I meant, there's, after the initial kind of conversion to HTML, you get, say, some conceptual understanding of the image. Are those things, are those features that you kind of, specifically prompt to the model to extract, or are those some a bit more free form and the LLM can pick any salient features it chooses to pick?
Oh, you're talking about the visual hierarchy stage?
Right.
Yeah, so I understand what you mean. Are you saying that is it robust and constantly classifying as the visual hierarchy is? So like what is primary, what is secondary, it's not?
Right, like, yeah, how is it doing the groupings just by itself, or are you kind of guiding it in specific ways? Maybe also the bug stage, like, do you let the model just look at the output and go, hey, this might look off, or do you have a specific cues, like, hey, maybe check for the positions of the different layers, relative
Yeah.
to each other, stuff like that?
Yeah, so for this stage, we gave it that representation that has both, the structural information, like the style information says like where it is, the bounding box, and then the caption. So those two helped give it the groupings. In terms of the sort of guidance, we let the model just group. So it was interesting to see that like, oh, it could actually group things. And it wasn't always just grouping based on semantic similarity of caption. It also could capture things that have similarity in terms of size and secondary elements and so on. In terms of guidance on the visual debugging, we were specifically checking for position, scale, and rotation. So those things. There were other things that we didn't necessarily check for, like edge case errors. Like sometimes the animation code would assign like a color change or something like that, but we didn't check for that.
Gotcha, thanks.
But that's nice. It's a nice segue into the results part, because I get to show you guys a lot of what I consider pretty animations. So we're getting there, and we're back. Okay. So Locomotion produced animation that was content aware and semantically meaningful. So for example, you can see here in the middle, there's this nightclub, and when it starts moving, it's pulsing and the neon lights are flickering. If you look at the hockey stick after the element comes in gives a little puck-like motion as if it's in play. And you can see the stars there. There's a lot of secondary elements that are animating into place, and then the full picture appears. If we look here at the lantern moves kind of as if it's in a breeze. When the icon of a martial arts person comes in, there's this little impact, and I found that cool. And then here we have a chess piece. It's being set in an L-like motion. That's what the design concept said, at least. But it was able to definitely connect to how objects move in the real world, or how we expect it to move on the screen. It could also implement logical sequencing, so layers with timing from bottom to top, and respect certain constraints like symmetry. So you can see that in the music notes there, in the way these layers time in on the right here. It was also capable of handling complex text effects, which is something that usually can be a little tedious to do otherwise, like manually.
Just a quick question about this. Was this like it actually animating rotations and translations of every single character, or did you have like a primitive in the language that it could use that did like a radial sort of, yeah.
Yeah.
Okay.
So it's easy to do that in code, right? And that's what it was doing. So in the reorganized HTML, it had like a CSS class. So it's like, oh, these are all part of the text group 1 or text group 2. And then it could just assign offsets, because in code, it's easy to do that and then create this.
Okay.
So that's what helped implement things like typewriter effects or fades and so on.
So when we say it implement,
DLM, logo motion, stage 1. Does that help?
yeah, the thing I'm missing, I think, is to what extent the human is involved in each of the stages.
Yes. Stage 1, automatic. Stage 2, automatic. Stage 3, interactive. So I'm getting there.
That's the design.
Yes.
Stage 1.
Huh?
Stage 1.
No. I'll get to stage 3 and I'll show the interface. But first, to just validate like the automatic approach, we ran a comparison study with Canva Magic Animate, which is this industry tool, and Magic Animate is a premium feature. And so we were just getting their outputs and comparing Locomotion to it, and we were validating that, okay, it's more content aware, but it's also on par in terms of execution quality and sequencing, which is pretty cool because that is a shipped product. And then we evaluated the program repair stage. We wanted to understand, okay, well, what sorts of errors are these stages making? And also how capably is Locomotion capable of debugging them? So in general, for Locomotion, 68.2% of the runs were error-free, but there were 32% that did need error correction. And so we did an evaluation where we borrowed from program synthesis literature and did a pass-at-K evaluation. And so what that means is we gave the model K attempts to solve something, and that in this case was self-debugging. So we would give the bug to the model and we would give it 1, 2, 3, or 4 chances, and we had 2 conditions. The first condition would pass in all of the information, so the images, the image pairs, the bounding box information, as well as the buggy code. But then there was another condition where we didn't pass in the visual information and we just gave the bounding box information and code. What we saw was that the visual feedback definitely did help. By K equals 4, it was capable of solving most of those errors. And this showed that at least having a layer-wise beam of focus did work in correcting errors. In terms of an empirical analysis of errors, these are the sorts of errors that Locomotion was capable of making, and here's some reasons why. So in an HTML canvas, there's usually absolute and relative coordinates. It would sometimes get mixed up between those. Sometimes it would set the structure wrong, so it had like a from to format that it wouldn't follow. And GPT being interactive would often assume placeholders and so on. And so then we had this code representation. Well, what was really cool was that it could power a user interface. So it would allow users to edit the motion, the groups, and the timing. And so there was a timeline stage where you could add things like, oh, maybe make the skier do a trick. But it would also represent the animation in terms of what is happening at each stage, because it's a lot for a user to watch an animation and then to understand it. So this broke it down. And there were also quick actions at the bottom for like make things slower or faster, synchronized, and so on. But one thing I'm really excited about is that this intermediate representation was then really useful for the layers panel, which is a really common feature in a lot of design tools. And users could move around the different layers, and that would change the representation that was sent to the vision language model. So here's one example of locomotion in action. So a user would first see an option that was generated by locomotion, and this one was a little bit clean, but maybe it could use some more. So it's just skiing into place, but the groups are quite okay. But a user could be like, can it do a trick after it comes in? And they would hit edit animation, and then it would do a trick. But what was really cool was that like the text was also coming at the right spot. There was this nice alignment. So that was one example. And then here's just one more video showing that when you change the different layers, here's one way that I would render visually. So if you started to group everything down, you could condense the amount of animation in case there was just too much animation. So when you hit regroup, you could get a nice synchronization. Because some people want a lot of motion, some people just want some clean amount of motion. So that was layer regrouping in action. And we conducted an evaluation with novices. And what we found was that novices really enjoyed working with locomotion, and they described how it enabled them to animate. They said it's really cool for somebody who couldn't do it without the tool and wouldn't spend a lot of time with YouTube videos or tutorials to do the very basics. They would try to make a manta kind of come in as if fighting against the current, and then the text would come in, or they would make that plumbing thing rotate and then water come out and then the text come in. Here are some other examples that I like. So there was this dinosaur coming in and the participant was trying to make it like jitter like a toy. And then there was this sweet home example where the hearts, they're bubbling up and the user could like make it flow like smoke. So that's locomotion. It's a vision language model system that helps users automatically and interactively animate static logos. And so that's multimodal reflection for design evaluation. In the interest of time, I'm going to more briefly talk about this sort of ongoing and future work towards a general framework for design iteration. So I talked about this sort of graph with like moving across different levels of abstraction and across different modalities, but what might be next? And I think about, I'm inspired by visual abstraction as well as design iteration. I've been thinking about this project called Canvas Agent, which is kind of inspired by now how I code because I often make user interfaces and I'll prototype. I'll be drawing a lot of gray boxes and expecting the model to understand what all of those gray boxes mean. So that's crossing a lot of modalities and different levels of abstraction. But what if we had a team of agents that help us operate over this canvas? And this is that team. So what if we had orchestrator agents that could orchestrate a team of agents so that there's some agents that understand layers, some that understand grids, others that understand best practices related to design libraries, for example, like React or Material, and most importantly, some janitor agents that can help you do cleanup work. So, for example, I'm thinking about agents that can operate at a high level and use Canvas awareness to suggest like what are the next features to implement. I'm thinking about agents that can cross the level of abstraction and help people with implementation. So you give it a low fidelity mockup, you've just drawn boxes, but it can implement that for you. Or even being able to understand really short commands like implement highlighted when active, so on. And then in terms of design evaluation, other agents that produce richer forms of Canvas feedback. So generator agents can help clean up code and clean up stray elements on a canvas, and they're operating over the specifics. And then layer and grouping agents that can help group layers and also regroup things. And we already saw flavors of that within locomotion. So that's Canvas agent. But that's how it supports those three stages. But in terms of iteration, when you have agents, they can talk to each other. And what if this sort of crosstalk can help move users more easily through the different stages of the design process? So that's Canvas agent. A general framework towards design iteration and how we can interactively align AI with the user goals and reduce usability friction. So that brings me to the end of my talk. We'll have some time for questions, but just as a quick recap, a thought I want to leave you guys with is that people want to create things, meaningful forms of their thoughts and their experiences. And to do this, they use the design process often to share what's on their mind, create that meaningful form, and pass it on to somebody else. And a way that we can use AI in that process is if we have interactive techniques for multimodal integration at each stage of the design process. So multimodal switching for design ideation in Opal, cross-modal mappings for design execution in Disco, multimodal reflection for design evaluation and locomotion, and moving towards a general framework for iteration in Canvas agent. So some other projects that I did, just as a brief aside, I did a paper on text to image that will be featured in a textbook, Introduction to Human-Computer Interaction, if you guys wanted to see that. For Fusion, for 3DALL-E, that's Project Salvador and Fusion 360. I have a lot of acknowledgements to make for people to attribute a lot of work to. So people at Columbia, people at Autodesk, people at Adobe, and people at Berkeley. So I'll leave you guys on this slide, and now I can take any questions.
You have a few minutes. Please. Questions for our speaker?
A really wonderful talk. It's really nice to see, I feel, successful cases of large language models collaborating with other vision language models and humans as well. My personal experience has been often these pipelines can be kind of brittle because prompt has to be specific to it, and then sometimes the models don't work as well as you'd expect. On certain examples, they work well. And I see some of your ideas like having like a self-debugging loop to improve it. But I was just curious about your take in general about these pipelines being brittle. What do you think about making them more robust, and what do you think would help apart from just self-correction?
Yeah, I definitely understand that. When I first started, the sorts of prompts that I was passing in were more about like associative knowledge, right? So like, what are like the 10 keywords, or what's the article tone? And I would say that that doesn't require a sort of heavy system prompt or something that's reliant on prompt engineering. And I try to keep that flavor in my work. And I think for locomotion, it's not like I was trying to pass in something that would create a form of code. I wanted it to integrate more world knowledge, right? So it's like, okay, well, how would you represent something like a lantern blowing in a breeze? I let the model handle that. I offloaded that to the model and then let it implement that language understanding into code. But I do hear you. When you have heavier prompts, things can be very brittle.
So one open question these days is whether who owns the copyright for the generative AI output. And one, so far, all attempts to register all output from generative have been sort of denied by the Copyright Office. And I wonder if this collaborative technique, if there like one sort of hidden benefit is that then the author can claim like, well, they actually contributed some creative aspect to the work. Like I think one guideline is like whether they did something, like they sketched something where the output was a sketch, right? So they did something in the form of the medium that the output was the medium. And yeah, I'm just curious if you have thought about that, or like if there's a way to like capture the like sort of history of what's been done so that the author can claim copyright later.
Yeah, absolutely. Actually, in my paper 3DALL-E, I proposed this idea about having prompt histories and how you can literally track all the different sorts of prompting, not just like text prompting, but image prompting. So it's like, here's what I had modeled first, and here's the sorts of image inspiration that this tool gave me, and then creating that history. And that's a form that you get from like an interactive interface. I do think that once somebody starts involving themselves and putting in the effort, then I think that that becomes something that is, in part, they have some copyright claims. Let's see if there's any other part of this question I need to answer. Do you have
The
any
part is
follow-up?
just there might be a hidden benefit with the collaborating because then it's much more like using a tool like Photoshop rather than like a director asking for like a certain like outsourcing work. So I think that's sort of
Right.
potentially a cool, like you could explicitly look for that line and try to make sure the author has a better claim to ownership.
Yeah. That reminds me, one part that I wanted to answer that question was, I think we can look back to a lot of the work that was done when Photoshop came in as a tool, because Photoshop, people, a lot of times in online communities, they would take a lot of different textures or photos from Google Images and then combine them and then create something. And at least we could look at the practices that people did online in those communities. They would attribute and say like, okay, here's the images and where they came from. Yeah.
Oh, yeah. I think the Canvas agent thing at the end of the talk was really interesting. And I'm wondering if it could help with these like creation of like these larger projects within like creative context, because a lot of, I think, the work we see, we create like single images, or maybe we create like a short video sequence, but it's not like we're creating an entire like webtoon or like a animated series, for instance. And I'm thinking, since you've presented this idea of delegating these tasks to different agents, and that's very much how it works in like industry, where you have like a look department, a modeling department, all these departments that collaborate and interact with these like different modalities. Like there's scripts, there's like mock-ups, character sheets and profiles, etc. And I'm wondering, do you think we can move towards that direction using this like idea of agents?
Yeah, I do think that a lot of the agent frameworks are moving people towards creating really complex things like full applications, trying to represent like maybe like an entire dev team. And there's tools like GPT Pilot that try to express that. Your idea is more about like creating like a longer term narrative, I think. And I think that some of the work that I've done is mostly around these targeted artifacts, but still in pursuit of like, hey, you have a visual message, how do you convey that? Potentially, I hadn't thought about Canvas agent in that aspect, like for storytelling, but that's an interesting idea.
All right, we're out of time, so let's thank our speaker one more time.